Hello everyone, welcome to this another lecture video for General Chemistry 2. So for this topic, it'll be divided into two separate videos. The first video will be on the concept behind colligative properties, and the next video will be on solving problems regarding colligative properties. So to start with, let's discuss what are colligative properties, or what does colligative properties mean. So to understand colligative properties, we will compare a pure solvent from a solution. So it is stated here that some physical properties of liquid solutions differ from those of the pure solvent. And these properties are called colligative property, which means that they depend on their nature. Okay, so colligative means depending upon the collection. Colligative properties depend upon the collective effect of the solute particles and not their chemical identity. So itong mga properties na pag-aaralan natin later, they depend on the collection or the concentration of the solute and not their chemical identity. And these four colligative properties are vapor pressure reduction, boiling point elevation, freezing point depression, and osmotic pressure. All these four colligative properties depend on the amount or the concentration of the solute in the solution and not their chemical identity. Yun yung pinapoint out kanina dun sa slide number 1. So let's discuss first vapor pressure reduction. So vapor pressure arises because some molecules of a pure liquid leave the liquid surface and enter the gaseous state, which is called the vaporization process. At the same time, molecules from the gaseous state return to the liquid or the condensation process. And when the rate at which two processes occur becomes equal, the processes are said to be in equilibrium. Now, so the gas pressure resulting from the vapor molecules over the liquid is vapor pressure. Now, experiments show that the vapor pressure of a solvent containing a non-volatile solute is lower than the vapor pressure of the pure solvent. Non-volatile means that a substance has no tendency to vaporize or sublime under existing conditions. Example is sugar, which is a non-volatile substance. This just points out that the vapor pressure ability of a pure solvent is or being slowed down by a non-volatile solute. So, ibig sabihin nito, kapag dinagdagan mo ng non-volatile solute, yung isang pure solvent, pababa yung vapor pressure niya. That's why it's called vapor pressure reduction. Now, when the non-volatile solute is added to a pure solvent, the solute molecules take up space at the surface of the liquid. This prevents some solvent molecules from leaving the liquid. Meanwhile, there is no change in the rate at which molecules in the gas state return to the liquid. Thus, there is a shift in the movement of molecules from the gaseous state to the liquid state. This just explains the process on how non-volatile solutes can reduce vapor pressure. Now, because more molecules leave the gas than enter it, the pressure of the gas is reduced. This is now known as vapor pressure reduction. Because the reduction in vapor pressure does not depend on the identity of the solute involved or its chemical properties, vapor pressure reduction is a colligative property kasi nagdedepende siya dun sa amount ng non-volatile solute na dinagdag dun sa pure solvent. And it does not have anything to do with the chemical identity of the solute that was added dun sa solvent natin. Now, the extent to which a non-volatile solute lowers the vapor pressure is proportional to its concentration. Now, doubling uh, the concentration of solute doubles its effect. Detailed studies of the vapor pressure of solutions were carried out by Francois Marie Rolt. Okay? So, ini-state lang dito kung anong relationship ng vapor pressure sa amount ng non-volatile solute. So, the higher the concentration of non-volatile solute dun sa pure solvent, the more na bababa yung vapor pressure. Now, the fact that the magnitude of the vapor pressure reduction is proportional to solute concentration is known as Rolt's law. So, yun yung tawag dun sa property na ito. Now, next colligative property is the boiling point elevation. So, have you ever seen an overheated car with steam rising from the engine pulled over to the side of the road? So, when the water in a car's engine boils, the engine can be damaged. Antifreeze is added to the water on a car's cooling system to protect against such damage. But how does antifreeze work? So, yun nga, this is just an example of the application of this colligative property which is boiling point elevation. So, dinadagdagan, it'll be explained sa next slide. Next. So, antifreeze raises the boiling point of the water in the engine. The boiling point of a substance is the temperature at which the vapor pressure of a liquid is equal to the external pressure on its surface, and in this case, atmospheric pressure. Now, because the addition of a non-volatile solute reduces the vapor pressure of the solution, a higher temperature is necessary to get the vapor pressure of the solution up to the atmospheric pressure so that the solution boils. The amount by which the boiling temperature is raised is boiling point elevation, which is another colligative property of solutions. A concrete example of this, if you haven't understand yung example dito sa slide, is the difference between the boiling point of a pure water and a solution of water and salt. So kung mapapansin nyo, I think this was done sa mga experiments nung junior high school, wherein you will compare the boiling point of a pure water and solution of water and salt. So kung mapapansin nyo, tumataas yung boiling point ng solution. So, in this case, yung water and salt. So, mas mataas ang boiling point ng solution kesa sa pure solvents. Just like yung water and salt solution. So, that's a basic example of boiling point elevation. So, antifreeze, usually ethylene glycol, is a solute added to water to raise the temperature at which it boils. Now, the boiling point elevation, T delta B, denoted by T delta B, is the difference between the boiling point of the solution and the boiling point of the pure solvent. So, it is directly proportional to the number of solute particles per mole of the solvent particles. Molality expresses the number of moles of solute per kilogram of solvent, which in turn represents a fixed number of moles of solvent. Thus, T delta B is proportional to molality. So, this is now the formula for wait lang. So this is now the formula in getting the difference between the original boiling point and the boiling point of the solution. So T delta B is equal to the constant boiling point of the pure solvent times the molality and its Van 't Hoff factor. So Kb is a constant called the molal boiling point elevation constant. And the value Kb depends on the solvent. And each solvent has its own value of Kb. So, here, we have boiling point elevation and we have different solvents here and their constants. Okay, so anyway, in problems later, sa mga bibigay namin problems later, the constants will be given naman. Okay, so you don't need to memorize this one. So, elevating the boiling point of a solution has other familiar applications. So, for example, when candy is made, a common procedure is to add a lot of sugar and a little flavoring to water and then boil to solution. So, as the water slowly boils away, the concentration of sugar in the water increases. So, this is just another example of the application of boiling point elevation. So because of vapor pressure lowering is proportional to the increase in concentration, the vapor pressure is reduced. So as the vapor pressure is reduced, the boiling point goes up. So a candy thermometer is used to determine the temperature of the boiling solutions. So this is, again, an application of boiling point elevation sa production ng candy. So when this temperature is sufficiently high, the solution is judged to be concentrated enough to be taken to the next step in the candy recipe. So let's proceed to next. So freezing point depression. So you probably know that putting rock salt on wintry roads melts the ice and snow. But do you know why? When the rock salt solute or NaCl dissolves in water, it lowers the freezing point of the water several degrees. The water, which normally freezes to ice at 0 degrees Celsius, will remain a liquid to lower temperatures. So this is just another application of freezing point depression. So kung sa boiling point naman, kapag nagdagdag ka ng solute, tumataas lalo yung boiling point niya. Sa freezing point naman, bababa pa yung freezing point nung solution. So, same with kapag yung water, dinagdagan mo ng salt, tataas yung boiling point niya, bababa din yung freezing point niya. So, ganon. So, if normally ang water freeze siya at 0 degrees Celsius, kapag dinagdagan mo na siya ng salt, maybe it will freeze at negative 2 degrees Celsius or negative 4 degrees Celsius, mga ganon. Depende dun sa amount ng salt na nilagay mo. So thus, it might not freeze until the temperature drops as low as negative 10 degrees Celsius. So this colligative property, which describes the ability of a dissolved solute to lower the freezing point of its solution, is known as freezing point depression. Depression kasi mas lalong bababa yung freezing point. So sa boiling point naman, elevation kasi tataas pa yung boiling point kapag dinagdagan ng non-volatile solute. So the freezing point of a substance is the temperature at which the vapor pressures of the solid and liquid phases are the same. So if the solid is non-volatile, the vapor pressure of the solution is reduced in proportion to the mole fraction of the solute. So it just explains how does adding of non-volatile solute decreases its freezing point. So this means that the temperature at which the solution and solid phase have the same vapor pressure is reduced. So the depression of the freezing point of water by salt is so important that it was once believed that a mixture of salt and ice created the lowest temperature that could be reached by humans. So in fact, Gabriel Fahrenheit, a pioneer in the study of temperature, used depressed freezing points for the low points of his thermometers. So the 0 point of the Fahrenheit temperature scale that was named after him was originally set at the lowest temperature that he could reach using an ice salt mixture. So this is just another fact regarding freezing point depression. So like boiling point elevation, the decrease in the freezing point denoted by T delta F is directly proportional to the molality of the solute. So the relationship of molality to the change in freezing point is given by the equation T delta F is equal to the constant times the molality. So the molal freezing point depression constant is the specific effect of a solute on a given solvent. So we already have constants for this one. So for example, ito, dun sa boiling point elevation, we also have constants na for boiling points. So ito naman for freezing points. So as I have said kanina, you don't need to memorize this one because it will be given sa problem. Next. So let's move on dun sa next colligative property, which is the osmotic pressure. So certain materials are semi-permeable. This means that they allow some particles to pass through but not others. A semi-permeable membrane may permit the passage of small solvent molecules such as water but not larger solute molecules or ions. So I know you have a background on what is a semi-permeable membrane is. I think one example of this one sa biology, we have the plasma membrane, which is a semi-permeable membrane. So next. So if such a membrane is placed between two solutions of different concentration, solvent molecules will move in both directions through the membrane, while solute particles will remain on one side of the membrane or the other. So this will be much more explained later kapag meron na tayong figure. So the result is a net flow of solvent molecules from the less concentrated solution to the more concentrated solution. So this process is called osmosis. I'll explain mamaya kapag. Okay, so this is now the figure and I'll explain how osmotic pressure uh, takes into effect. Okay, so this one, so we have here a U tube separated by a semi-permeable membrane. So meron tayong water dito, meron tayong solution dito. We have solutions on both sides separated by a semi-permeable membrane. But then this side, dito sa left side, mas marami ang solute and the other side, mas konti ang solute. So the movement of water now, so ang goal kasi dito, dapat maging pantay yung concentration. So since mas madami ang solute dito, tapos lesser ang solute dito, that means the left side needs more water and the right side needs less water. So now the movement of water is from the left side, from the right side to the left side. So that's why the final state, eto. So mas konti na yung water sa right side kesa sa left side. Okay? So yung water lang ang nagmo-move since this is a semi-permeable membrane. So it does not allow itong solute natin to move. Okay? So next. So the figure shows two solutions separated by a semi-permeable membrane. Solvent moves through the membrane from right to left. So as a result, the liquid levels in the two sides of the tube become uneven. Now eventually, the pressure differences resulting from the uneven heights become so large that the net flow of solvent ceases. So mag-i-stop na yung flow of water from the right side of the tube to the left side kapag pantay na yung pressure, kapag pantay na yung concentration nila. So the pressure required to prevent osmosis is known as the osmotic pressure, denoted by the pi symbol. of the solution. So now osmotic pressure is another colligative property of solutions. So osmotic pressure can also exist between a pure solvent and a solution. So what do you think happens when two solutions with identical osmotic pressure are separated by a semi-permeable membrane? So the answer is that no osmosis occurs. So the solutions are said to be isotonic. So kapag pantay yung concentration dun sa both sides separated by a semi-permeable membrane, hindi na siya gagalaw because the solutions are already isotonic in nature. So one practical application of osmotic pressure is in the administration of fluids intravenously to people needing replacement of body fluids. And these fluids must be isotonic with body fluids because the membranes of red blood cells are semi-permeable. So if one solution has a lower osmotic pressure than another, it is said to be hypertonic. So placing cells in a hypertonic solution would cause water to leave the cells. This causes the cells to shrivel and die. So in a hypertonic solution, mas concentrated siya. So let's take for example, nilagay mo yung isang cell sa isang hypertonic solution. Now since the solution has more concentration than the inside of the cell, this will now cause water to leave the cells, making the cells shrivel and eventually die. Okay? So, that ends itong discussion natin for colligative properties. And on the next video, I will discuss how to solve problems regarding colligative properties. That's the time also wherein I'll be presenting yung different formula na gagamitin natin for every colligative property. So that ends our discussion for this video, and proceed to the next video for the problem sets.